Hi students, it's me again. Here's the promised video on SADMEP to the rescue. SADMEP, what does that mean? Well, you all know PEMDAS, right? PEMDAS. You use that when you already have numbers in your equation and you want to know the order of operation to use. For example, if you have something that's squared, you have to do that first before you subtract something from it. Now, PEMDAS only gets us that far if we're trying to solve our equation for an unknown, and all we have is the equation. And trust me, it's a lot easier to solve the equation first before you plug in numbers, especially if they're especially big or especially small numbers. It's much easier for us to rearrange the equation. What you do want to do, though, is write your equation always in the standard form, because that gets you the point in case you rearrange it incorrectly, okay? Now, we have learned with v equals d over t that we can use a triangle. So that was easy because it only had three variables. If we look at this equation, a equals delta v over t, we can use it the same way. What's on top of the equation? This one here. So delta v is up here, a and t is here. If you need a, it's delta v over t. If you need t, it's delta v over a, or if you need delta v, it's a times t. However, that only works if we have one of those three things given. And most of the times you don't have delta v given, but you have initial and final velocity given. So let's look at this formula. That's also number 2 formula. A equals final velocity minus initial velocity divided by time. Let's say we need final velocity. Okay, since final minus initial velocity is on top of the dividing line, that's basically as if they are in parentheses. You can't touch them until the dividing line is gone. So what do we have to do? We're going to use SADMEP to decide what we get rid of first. So is anything subtracting from final velocity? Yes, but right now it's still in the parentheses, so we can't touch it. Is anything adding to it? No, there's no plus sign. Anything dividing VF? Yes, time is dividing it. So we get rid of time first. And how do we get rid of time? We play opposite games. If it's dividing, then we have to multiply it with each side for it to disappear on the right side. So if we do the right side times time, and we also do the left side times time, then on the right side, it will fall away. So a times t equals final velocity minus initial velocity. Now we don't need the parentheses anymore because there's nothing else there. And we can basically start over with our SADMEP if we want, or simply get rid of the initial velocity. What is it doing? It's subtracting from final velocity. So we play opposite games. We add it to both sides plus initial velocity. And then it falls away on this side and appears again on this side. So you have VI plus A times T, and that equals your final velocity. And if you look at equation number 3, that's exactly what it says. So actually, number 2 and 3 are the same equations. Let's go do something a little more difficult. Let's go use number 5 equation. Equation number 5 says distance equals initial velocity times time plus 1/2 times a times time squared. You're actually going to use this one a lot. And what you use it for is to find time. Well, that looks pretty complicated because we have time in here 3 times. 1 time here squared, and then we have time here again. So we would normally use the quadratic formula for that, but we're not in AP Physics, so we're not going to do the quadratic formula for anything this year in my physics class. You only get this formula to solve it for t if and when your initial velocity happens to be 0, okay? So initial velocity is 0, because what happens if initial velocity is 0? This number is 0, and if you make 0 times any number, such as the time, then this whole term is going to be 0. That means we can just take it out. And that shortens our formula to distance equals 1/2 times a times t squared. Now we can start with SADMEP. Or actually, before we start with SADMEP, here's the thing. If you make something times 1/2, it's the same as divided by 2. So if you make 1 times 1/2, your result is 1/2. It's the same as making 1 divided by 2. So we can rewrite that as a times t squared divided by 2. And that equals the distance. Okay, let's circle what we're looking for. I'm going to make a red circle around this. T is what we're looking for. So we have to get rid of 3 things: the acceleration, the number 2, and the square. Okay, let's use SADMEP. Do we have anything subtracting from t? No. Anything adding to t? No, there's no plus sign. Anything dividing t? Yes, the 2 is dividing t. So we get rid of the 2. How? We play opposite games. If it's dividing, then we have to make it times 2 on both sides. On the right side, it will fall away. On the left side, we will see 2d equals a times t squared. Okay, that looks a lot easier already. Done with the division. Multiplication, do we have anything multiplying t? Yes, we do. It's a. A is multiplying t. So we play opposite games again. We divide both sides by a, which causes it to fall away on the right side. And then the last thing we have is square. What's the opposite of a square? It's a square root. By the way, if you forget what the opposite is, you can find it on your calculator. Usually over the x square sign is the sign for the square root, and you get with it to that with the second function. So let's see if you can see this. Here on the calculator, you see the x square, and right on top is the square root. You get to that with the second function. And that is simply the opposite. Usually that's the way it is on calculators. Okay, so we square root the right side. We also have to square root the left side, and then that gives us t equals the square root of 2 times the distance over a. Now, everything's under the square root, so don't write it like that. All right, that would be wrong. Don't write it like this. The whole side will be under the square root. Okay, one more. How about the longest, most difficult one? That's number 6. Final velocity square equals initial velocity square plus 2 times the acceleration times the distance. Okay, let's see. Let's say we would need initial velocity. I'm going to circle that so you don't lose track of it. We need initial velocity, and we have everything else given. Again, we use SADMEP. Is anything subtracting from initial velocity? No, there's no minus sign. Anything adding? Yes. What is adding? This whole term here is added to initial velocity. So that means we can get rid of it all at once. How? Simply by subtracting it. We make minus 2 times a times t on the right side. That makes it go away. We also do it on the left side. So then we have final velocity square minus 2 times a times t, and that equals initial velocity squared. But we only want initial velocity, not the square of it. So what we have to do is use the square root on both sides, and then I have the answer. Initial velocity is the square root of final velocity squared minus 2 times a times t. So first you have to square the final velocity, then you subtract 2 times a times t, and then you take the square root, and then you have your initial velocity. See you later.